So, for those of you who may not know who I am, my company is Team Immersion Technologies. Our company is primarily focused around training IT pros on how to use Microsoft AppV. And then today we're announcing that starting next year, we'll start doing classes which will be a packaging for AppV and MSI X. So we'll kind of combine the two and let you understand the best of both worlds. I do a lot of the training through the folks here at PDS here in the Netherlands. In fact, I have a AppV class next week down in Culemborg. But we try to hit various areas within Europe as best we can, although I'm based over in the US. So let's start talking about some things I talked about at this show last year. This is one of the slides. I talked about what I see happening in particularly the larger enterprises as they bring applications through to deliver them out to the desktop. And I see a lot of parallelism going on, where we have different teams of people who are packaging the same application in multiple ways. Different teams doing it, using different pieces of technology, and quite often struggling with an application multiple times when they're not really sharing the information about what they learned. So you may have some people who are putting it out on the image to one group of people. They may be using Configuration Manager with some maybe MSI repackaging that's going out another group. You got the Citrix team that doesn't want to go near either one of those things, so they're delivering it through AppV. They may be using some of the new app layering stuff, but you have these different teams going out. And a couple years ago, I recognized this, and I wrote a paper. We put it up on the Tech Target site, and it kind of looked like this. And what I was saying was, I would love it if we could have one tool chain that worked really well to do the packaging and configuration for the enterprise. And once we got the package, then split out to the different ways to deliver that software out to the end users. And at the time I wrote it, I said, you know, when I look at the different formats we have out there, AppV is probably the closest thing to a good format to have at this point, in the way that it could be flexible. Even though we're really only deploying it through the AppV client today, there's really no reason we couldn't have tooling that would turn that into these other formats going out. And I said AppV probably isn't the perfect format, but it's the best we have today. And I would love to stand here today and say that Microsoft heard what I said and therefore developed MSI X, and that's what they're trying to do. Unfortunately, I have no proof of that, so maybe I'll just take credit anyway. I don't know. All right. So what we've been doing in the AppV world has been trying to improve the process of bringing this software out to the end users. And sequencing has always been considered to be very hard, but quite frankly, it's the applications that are hard. But we've been making improvements over the years. In fact, it's actually become a little bit easier with some of the tooling we've done lately because the AppV platform itself has become stable. So we've been able to do more advanced tooling. And so when I was here last year, I talked about the AppV Manage and the Analyzer and the silent install stuff that we were doing, where we would take the package, we'd sequence it, we'd bring it into this Analyzer, which is a free community tool for you, and it would tell you problems that it would detect in the software based on the way it actually got laid down. So that meant it covered not only the things that we could see in some of the third-party tools that are doing MSI scanning, but actually all of the results out of the custom actions. So it's actually looking at it at that level. And it would produce a PowerShell script to help you fix that application up. So if the application vendor did things like they set some file associations and really didn't do the registered applications that they should do, we would help you fix that automatically with just a push of a button. The process was you'd go back to the sequencer, recapture that package, and run this extra script as part of it, and it would fix up that package. And that was okay. What I've done this last year to advance that, there's a new tool called TM-Edit, and that one, unfortunately, is not free. I'm going to charge you for that one. But what it'll do is it'll take that package, do the analysis, and just fix the package directly. So you have a simpler tool chain to go through. So that's kind of the latest stuff that we've been doing there. And with that, we can produce packages which are better than what the software vendor delivered to you. It operates better, takes care of things like the last write wins on those file associations, other problems that they may impose, problems that are specific to that delivery mechanism of AppV. So for example, we have some problems with shortcuts in some cases. And also is optimized. So things that are .NET that the vendor didn't properly optimize will take care of those types of problems as well. And that's really become a pretty good tool chain going forward. Oops, I didn't have to click through that stuff. All right. But that's not why I'm here today. Today I'm here and I really only have one job. Okay? And if you are a developer, MSI X, I think, is going to be fantastic. If you are an IT pro and you get packages that are MSI X enabled from those vendors, it's going to be relatively easy for you to consume and use those things. But my one job is to convince you not to be overly excited about MSI X right now. Okay? I want to take you from being there after seeing the great demo this morning from Microsoft and how easy everything was and stuff magically worked, and I want to get you into that mildly enthusiastic state. Okay? This is a technology that you should be looking at, but you should not be thinking that next year you're going to take all of your software and you can do this repackaging and you'll just deploy everything that way in the future. It probably doesn't make sense to do that yet. We need time for that technology to evolve. Microsoft, when they announced it last summer, said that they're going to release the technology over the next few releases of Windows. So it's not complete. We saw a few things that Microsoft said that they're going to add in the near future. So they were talking about the February to March type of time frame with the newer version of Windows. But you're going to need to take that newer version of Windows to be able to get access to that. And they're still going to have more to do, and we don't have the roadmap of what all those things are. Okay, so let's talk about MSI X and the way that I describe it. And so I end up wanting to describe it in 3 separate pieces, because there is a format piece, and that's really what we've been doing a lot of looking at. There's the delivery piece, and then there's the runtime piece. That's the part that gets delivered with Windows itself. The format, you know, you've heard a lot of the stuff from Microsoft today in terms of what that's all about. The runtime, it is running in an isolated container. So for those of you who are familiar with AppV, we're running in, we could use the term container, but we've never used it. We always use the word bubble for that. But you're running in an isolated environment. And Microsoft did a good job of taking the original product that I built that was really overly isolated and rebuilding that with AppV5 to kind of cut down on that amount of isolation because it caused a lot of problems with applications. As we run in MSI X, we're running in a true container. So we're kind of going back a step, and we're going to need to do some more work to get some of those older applications to work. Okay. So from a format perspective, in every case on the screen here, we've got an AppX base in terms of the format description with some extensions to it. And AppV had a very large extension set to it. Centennial, that was the Windows Bridges thing, that had a very small extension to it. MSI X is going to be bigger. Right now, it's not much bigger than Centennial, but over time, that'll probably grow a little bit. I'm sure it's never going to get to the size of extensions that AppV had. So what are these extensions about? These extensions are about the integration of that application into the operating system when you drop it down and do the quote-unquote install to it, right? So we have to put shortcuts. We have to put file associations, right? Those types of things, protocol handlers. Those are built into the extensions here. But many of the other things that AppV does won't be there, and we need to either make sure that we don't need them for that application or that we can work around it through another method. Now, this is a chart that I made from basically the deliveries and the types of formats we had available a year ago. And the big thing to notice in this chart is pretty much we got checkboxes up in this corner. If you have traditional applications, you could deliver them through traditional methods. But if you had modern applications, you needed to deliver them through the modern delivery methods. And what Microsoft has done through releases this summer and the announcement at Ignite is they're starting to fill this chart out a lot more and giving you the choice for both the older and newer applications for your delivery model. And this is great. This is exactly what we did need. We needed Microsoft to allow you to make the choice of the application and the delivery method. And I was very glad to see that happen. This is a process that I have seen enterprises using to bring and onboard applications or go through migration projects. This is a set of things that you needed to do as you went from, say, Windows XP to Windows 7. And you had to take all of your applications and go through this process. And one thing I want to point out with MSI X, Microsoft says, hey, you shouldn't be doing this. MSI X is going to solve that for you. They're half right. You shouldn't be doing it. That's the half that's right, okay? Because as you go from Windows 7 to Windows 10, Microsoft has done a very good job on app compatibility. If you have an application and you've packaged it up and you're delivering it through a method on Windows 7, there's a pretty good chance that if you deliver that same package with the same delivery method on Windows 10, it's going to work. And as you take a new Windows 10, it's still going to work. Microsoft is doing a fantastic job at that right now. As I talked to customers last year who were moving to Windows 10, they were thinking about this process to do that move to 10. I kept telling them, no, don't do that. Spend your time and energy worrying about how the operating system itself is different, how you have to services it different. That's where IT should spend its capacity of time and money, and just assume the applications will work. Yes, you have to do a little bit of testing, but it should never be this process anymore. I like to look at MSI X from a Windows API coverage area. Particularly, we're talking about those old applications that you're not going to take or get updates from the vendors, or maybe those in-house applications that were built 10 years ago that you're just going to use the way it is today until you have to retire that thing. And for those applications, the Windows API becomes a very important measuring stick for how good the compatibility will be with taking that application and moving it into a new delivery and runtime technology. The Windows API itself is over 30 years old. It's changed every 2 years. And I'll give you a little secret. Microsoft doesn't even know what's in there sometimes. Okay? As I talked with the development team, the AppV team, they had these extensions like the Internet Explorer extensions, or the shell extensions is probably a better case. There were, I think, 20 different types of shell extensions that we've been able to identify. AppV, in terms of what was written on the paper, in terms of what it would support, was only about a dozen of them. Why weren't the others included? Because Microsoft actually had no way to test it. They know that the API exists. They find signs of it either through some code snippets that still are around or a piece of the documentation that's still around. So they knew it existed, but they really don't know of any apps that use that API, and so they didn't test it. Now, we found some of them. We found apps that use them, and we tested it, and sure enough, they worked anyway. But as I said, Microsoft doesn't even necessarily know everything that's in there. So AppV, it turns out, supports most of that Windows API. There are things like device drivers and COM+, WMI providers, or event trace providers. Those are the big four that AppV doesn't support. But pretty much the rest of it, it supports. AppX, technically I should have a little bit to the left. It doesn't actually use the Windows API. When they built the AppX technology, they took the Windows API, the WPF portion of that, and they kind of rewrote it to be that portable version that would run on all these other operating systems like iOS and the like. And that is very small footprint. It's nowhere near as big as the WPF API. And that's really why enterprises didn't go to AppX. I'm sorry, enterprises. Wrong answer. I'll rewind that. And that's really why ISVs didn't go to AppX. It was enough for the consumer space in many cases, but enterprise scale applications, they really couldn't do what they wanted to in AppX. And that's why Microsoft had to try to move to Centennial, and that kind of expanded the Windows API footprint. And the big question for us right now is, what is that coverage going to be for MSI X? If we listen to the original announcements that Kevin Gallo did at Build and then at yes, the Windows developers, he seemed to indicate that they were going to cover everything. And that's not going to be the case. Okay, it's going to be something smaller, and we really don't know where that's going to be. Microsoft doesn't necessarily, they haven't shared with us a roadmap that says how big that's going to be. Right now, it's probably right around there. You know, we saw the thing this morning. We don't have the virtual services and a few other things. The bigger this is, the more successful MSI X will end up being in the marketplace. All right. So I did some testing this summer. I got access to the early builds, and I shared this information with Microsoft. And I want to try to put a little bit of reality check into you. I took a number of applications. Most of them were things that enterprise had been using, and I'd been talking with them. I knew that this was part of their app portfolio. A few of these were very specialized tools that I wrote. I write a lot of really bad applications intentionally, and so I use those as well. And I simply took the packaging tool the way you saw it today without any fix-ups, and I packaged these up and I tested them. And these are the results that I got, right? Very small checkbox there for the green, meaning it really worked 100%. I was very happy with it. The ones in the red here, I could not launch the application. Okay? The ones in the yellow, I could launch the application, but there was something missing that you would probably not release that out to production because of the lack of that feature. Okay, you could get productive work done, but it really wasn't up to the quality. We saw 2 apps today in that demo from Microsoft. We saw Notepad++. That was in my yellow area. Okay, why was it in my yellow area? Because at that point, and Microsoft has since fixed it, right? This is old information. We didn't have support for the file associations. So you were not going to put out Notepad++ without the file associations. So in the stuff that comes out next week, I think we're going to see the file associations, so that would move into the green box today. We also saw VLC, right? Yep. So VLC is in the red. VLC, packaged the way we saw it on screen, doesn't launch. It gets an error. Now, why did it work? Because we saw it on screen today. It worked today, I believe, because he installed it on a VM, and without uninstalling it, he then ran his package, and that solved the problem. That's the one that really needs a fix-up right now. Okay, so good. I think I got you past the overexcitement. Excellent. I've succeeded. Yay! So as I looked at these applications, the funny thing was, none of these applications really had the same problems. They were different things, and I've provided a lot of feedback into Microsoft through the community portal and the feedback tool about these, and I know that they're working on a bunch of these things. So I'm not too worried about the things I identified. Let me give you a more concrete example. This is one of my really bad apps. Okay? I originally wrote this app during the transition from XP to Vista. And this is a stupid little app. It does nothing but provide data as part of the install that the user wants to change. And so it tries to put data in all the places that an app might try to do that type of configuration. So it puts things in a file under the current working directory. It puts things under app data local, app data roaming, and C program data. Okay? It also puts things in current user and HKLM in the registry. I added some stuff in on some environment variables, but that's an AppV specific kind of thing, I thought at the time. But if I just installed this application on Windows XP, everything here would work. I could make changes to stuff, and I'd see those changes and get access to them. That was great. Now, I take that and I run it inside of AppV. And all I do is package it up. I don't try to do anything special. And sure enough, when I run it, it can read all of that stuff out from the packaging, and everything works just fine. As I go to make changes in AppV, I do have a problem, which is the environment variables here. They don't actually change. AppV actually captures the changes and writes them out appropriately in the redirected area for the user, but it doesn't actually use it when you bring the application back up. So that was always a bug, and they never fixed it. But it was kind of okay, because there aren't that many applications where the end user changes the environment variable after you've delivered it. And that's usually something you're taking care of up front, There are a few developer tools where you might want to do that, and we'd have to kind of work around it and kind of keep this environment variable out of our package to get that to work. But what happens when I try to do this in MSI? OK, this is the right test. I should have clicked. What happens when we try to do this in MSI X? So taking that application, just running it through the tool, not trying to do any type of fix-ups, this is what I got. Okay? It couldn't find the data on these three pieces. They're there in the package. They were properly captured, but it couldn't find it. The first case is different from these two that are missing. The first case is a current working directory problem. AppX doesn't have the concept of a shortcut that sets the working directory. And by default, it assumes that the System32 folder is the current working directory. This particular tool happens to say, what's the current working directory, takes that, appends on the stuff it needs, and ends up looking for something in a place that it doesn't exist, because it was actually C program files, blah, blah, blah. So that's why that one didn't come in place. The program data did work. That worked because of the VFS pathing. So they're overlaying the VFS pathing to catch those things, and when the app asks for it in this location, it actually finds it under C, program files, Windows apps, the name of our package, root, VFS, I think they called it app data common, which is the same as the AppV name for that, and then the path under it. So the runtime engine automatically catches that and fixes it for us. It doesn't in the case of the app data roaming and app data local, which I consider to be a bug, and we've reported that in. For some reason, they're not doing the VFS pathing on that. And so we find out through procmon traces that it's actually looking at that location, and it doesn't exist there. It didn't get that redirection for the layering in there. The environment variables are not looking at it at all. So if we want to push out environment variables, unless Microsoft adds support for that into both the format and the runtime engine, we won't get those. All right. Now, what happens if we try to make changes to these things? Well, OK, well, first of all, I did take the PSF, and I used the PSF, which you use a shim launcher. So your shortcut points to this shim launcher, now called PSF launcher. They've renamed it on me. And that is included in your package. And then the PSF launcher would then launch your application, and therefore you get an opportunity to set the working directory. So I did that. Normally, this is where you'd also have that thing throw in some shims to work around problems, but I just did that first piece. And when I did that, sure enough, now it could read that data. But now I want to go and try to write that data and have the user make changes to it. And what I found is, for all of the file-based stuff, without any shimming in here, I can't do it. Now, if anyone was in, whose session was that today? One of the vendors. It was a RayNet session. They showed an example of this and said, OK, but we can solve this. We can use the file directory shim that Microsoft is providing in the PSF. So I could allow you to write to that file, but it would get a redirected write. And that's fine, except if you put in the shim directly out of Microsoft the way it's written right now, what you don't get is access to the original data. As soon as you put that shim in, it would never see this value here. It would look more like that. So the user wouldn't get their defaults that you put in the package. They could only make changes. What we really need is something that actually takes the stuff out of the package, copies it over there, and then allows you to modify it, which is exactly what AppV does by default. OK. Also, in the packaging tool, Microsoft didn't happen to mention that today, but they have the ability to convert AppV packages. Now, again, this chart here is out of date already. It was done the week after Microsoft made the first version of the tooling that could do the AppV conversions available to me. And I took a big set of AppV packages that I had and ran it through. I found some of them didn't convert at all. Those were simple bugs. I'm sure they fixed it by now, but I haven't been home to test it with the newest versions. But I actually started to see a little better, whoops, wrong button, a little better support for things working straight out of the box. Now, I was using slightly newer versions. That was some of it, and some of it was I had a much bigger package set. In the original set, I was kind of catch one thing in each different area, and a lot of these packages were actually similar and happened to be in the sets that were working. But I also saw a lot more in that red area, which concerned me, and I'm not quite sure what that was about. But in the long run, Microsoft is going to do a great job in the conversion, but you still are going to have to think about shimming those things. So it's not going to be as simple as running a script that just turns all your AppV packages into MSI X. You're going to have to go through the process of testing them out and shimming them to get them to work. So, so this is that PSF that they've been talking about. When you end up using the PSF, you have to create this JSON file. Now, why they pick JSON as a format is just absolutely beyond me. We're not doing anything with a web service or anything like that where you want to use this modern format. I really feel that XML would have been a much better format for this, something that's self-describing and easy to understand what the syntax is allowed to be by just publishing out that schema. But that's what they chose. The way this ends up working is you identify the applications within your package, and then for that application, you define what shims you want to put in, which is basically a DLL. And so this is the file redirection shim, and then you're configuring the file redirection shim here to say, hey, if you see something with this as the folder and a file looks like this, then I want you to do a redirection. And what it'll do is it'll do a redirection to the user's app data local folder. So one of the things that we need to do as a community, which I'll get to eventually, I hope, is to update the stuff on GitHub to give you some flexibility to say, no, I really want this one to go to the app data roaming folder because I've got users that are going to be roaming from machine to machine, and I have to have that data follow them. So we're going to need that. Microsoft has sort of forgotten that lesson, and we need to bring it back. All right. This is the list of shims that they have. And basically, they have a file redirection shim, which does file and registry redirection, if you like. And the others are things. This trace shim is an interesting one that I've been working with. I'll talk about in a little bit. So if you've ever looked at the Windows operating system and filter mode drivers, you can run a command called fltmc, and this is an example of its output. The interesting ones to look at here, the filter drivers, are this WCIFS, which is the Windows Container Isolation. You'll always see that one. And then after you've run something that's AppX, Centennial, or MSI X, you'll also see this WCNFS appear, and it stays on your machine until you reboot after that. And these are the ones that are involved with Windows containers. Initially, I thought this was where a lot of the MSI X stuff would be built in. And I was kind of surprised when I finally figured out, no, it isn't. It's actually somewhere else. But we also love to use procmon, so I kind of showed where that fits in this stack. The way this works is the application is kind of sitting on top. It's making a call down to the file or registry system, and that call has to go through these filters. And each filter gets an opportunity to do something about that call. And that's where, like, AppV will do a lot of its redirection activities. OK, so we take a look at a system, and filters have this thing called altitude, which kind of defines where they are. So we can see our 3 ones there. So for those of you familiar with AppV, AppV, had 3 different drivers in there, right? So the AppV VFS was responsible for doing that VFS overlaying thing that we talked about earlier. The AppV Stream was responsible for figuring out, do I have all the bits on disk, or do I have to go out to the network to go get them and bring them in? MSI X does not have streaming. Okay? It does some other nice things, like the single source on a per block level, so that as you update an app, only the changes have to come over the wire to go down to disk. Those things are really cool. I wish AppV had some of that, which it could. They just never built it in. But it doesn't do streaming, so they really don't need that driver. This one down here is responsible for figuring out that an application is supposed to be put in an AppV virtual environment. So MSI X needs something like that built into here. I'm not sure where it is right now, but I'm kind of guessing that's inside that WCIFS. Okay? But as I said, I'm not real sure. So you have your application, it goes through here. And so when you just do the packaging the way we saw it today without any fix-ups, the model kind of looks like this. You got the app up there. It's calling through. There are some standard shimming-like things that they're doing that I kind of draw right here based on my analysis. I believe it lives inside of NTDLL. And so that VFS tracing we'll see is happening up at that level. And then it would follow through that stack. If you're going to use something with one of the fix-ups, you're actually going to have a shim launcher that starts up. That shim launcher will be appropriate for the bitness of the application you're going to run. So there's a 32 and a 64-bit version. And then it is responsible for starting up the application. And it's going to throw some shims in there. It has some of its own it has to do. And then any other shims that you have based on that configuration will get loaded into that process space. And so it kind of will walk down through a path like this to get down to the machine. Now, there is this thing called trace shim. And trace shim is helpful for us to figure out what the problems are and where we need to do that shimming. So if you take a look at an old Win32 app, and let's say it wants to open up a file for some purpose, that app is going to call a thing called create file, either create file A or W, depending on if it's wide or ANSI strings, and that lives inside a kernel 32.dll. That actually then calls another function which has the same name in kernel base.dll. That has to do with the way Microsoft tried to split things out to make things like Windows Core possible with a smaller footprint in it. And then from there, it'll end up calling this NTDLL. If I click that button, we'll see that, it'll call NT create file, which lives in NTDLL, which then pops into the kernel and has a ZW equivalent, and then it'll get down into the filter mode drivers. That's kind of the way that whole pathing works. Now, if I have a .NET app, it's probably going to use a different path. In the case of .NET, it's going to call something like file.open, which is a .NET-based DLL, and then it'll eventually end up in this NT create file. So as we try to run trace shim to figure out what's going on, we have to concern ourselves with where should we be doing this tracing. We could be doing all of our tracing here at the NT level, because then we could catch all of those cases. But it's actually more helpful when they're calling through this path to do it at a higher level. And I also just point out there is .NET code that uses primary interop, which means the pathing actually does go that way on those calls as well. All right, so let's look at an example. So what I did is the trace shim that Microsoft has, the output to it is horrible. Okay, you have to use something like debug view tool to actually display it. And for any event that happens, you can basically get a full screen of text that tells you about that event. It's very difficult for you to work with to figure out, oh, where is the thing that I need to fix because my app is broken? So what I did is I decided I wanted to use an interface that looked something that would be more familiar to you, something like Procmon. So I've created a version, and we're in the process of getting that put into the GitHub repository so that it'll be available to all of you. So that's turned out to be a much more lengthy process than I thought it would be. For example, one of the things I found out within this last week is that Microsoft doesn't actually use that GitHub as their source control. They have another place, and sometime since the last time I looked, they actually replaced the whole thing. So I have to manually go in and figure out my changes because they've renamed a whole bunch of things on me. But anyway, we'll have this tool for you eventually. So this is an example of running it against that app I showed earlier, where it went and looking for the app data, for the current working directory piece after I did the fix-up for setting the current working directory. So at a create file level, remember we had these two levels, create file and NT create file. Where is that button? There it is. Create file made a call, and we can see it's asking for the thing here as a single call. But there were actually two calls here for NT create file. And the first one got denied, and the second one worked. And this is why tracing at the higher level makes your life a little bit easier. So what it did here is, for some reason, create file calls down with an attribute set, which was off the screen over here. You can't see. Isn't that great? I thought I had it on the screen here. Nope, I don't see it. It had a setting there that said something about encryption. I can't remember the exact term they use on there. But basically, it was trying to open it with an encryption enabled. It's not encrypted in any fashion. I don't have BitLocker running, so that actually got a failure, and then it made the same call without that setting, and then it succeeded. Right? So that's the kind of thing that we can end up seeing. So one of the things that I end up doing a lot of times, and by the way, if anyone sees Mark Ursinovich, don't tell him about this because he'll take it away from us, is we can actually move that Procmon driver in our filter stack. And this is how I find out how vendors are doing things, and sometimes how I can isolate a bug. There was a very famous case where I isolated out an AppV bug, where they were setting the short path incorrectly, and we were getting file names like foo.txt tilde something or other. Right? It was actually a bug in the AppV VFS driver, and I was able to isolate it by doing a Procmon trace above it and then a Procmon trace below it and proving out that they were causing that problem. So in this case, what I want to do, this is just a standard trace with Procmon in its normal location, which is in between the WCNFS and the WCIFS driver. And if we look here, we can see those two create files. Those are the two, this is a Procmon trace now, right? So this is those two NT create file calls that were made. So we can see them here. All right, so now if I look at the full set of calls involved when I do a Procmon trace, I actually had 5 calls in here. I had the 2 create files, then I'm seeing a read file. I didn't see a read file in the trace from the trace shim because trace shim doesn't trace the read and close and write calls today. That's another thing that I have to fix at some point, or maybe somebody else could fix so I don't have to. That would be nice too. But at the Procmon trace, we would see those. All right. So what I did is I moved the Procmon up above WICS, because one of the things I want to find out is where is that VFS work being done? I assumed that it would have been in the WCIFS driver, so I moved Procmon down below and ran a test. I didn't see any changes. So then I moved it up above WCNFS, thinking, well, maybe it's happening there. And what I found is that it wasn't happening there at all. So this is an example of moving it. This is the read below WCS for the case of the, this is the, sorry, wrong test. This is actually that same CWD test. As we see, as we move down below WCIS, I see a whole bunch of things. So WCIFS is doing a lot of things itself beyond what was coming down from it. So that second create call here came down, and it also made a bunch of subcalls itself, looking at some of the properties of the file itself to decide what to do. Okay, this is the example I was starting to talk about, which is the program data case. Okay, so this is a test in the trace tool. We see a create file, which did eventually return with a success. We saw a trace file with the error that was involved. And then we see an NT create file here where it succeeded. So it was very much like what we saw in the other case. Notice the pathing here in every case, it's still asking for C program data AppV personalization. So at the point that we got to that NT create file call, wow, 5 minutes. We were already at a spot where it was still looking at the original pathing. So VFS redirection hasn't happened yet. Okay? So now I ran this in Procmon, and in Procmon, I actually saw the redirected paths, even when I moved Procmon up above WCNFS. So that's why I said that NTDLL is probably where Microsoft is doing that VFS redirection today. Okay. All right. What does MSI X replace? Of course, Microsoft would love to replace the MSI and have that go away someday. Yeah, but they also want to get rid of your AD controller and all sorts of other things that you're probably not willing to give up. So these are technologies that are going to be around a while. It will affect these other areas. Okay, it's going to affect AppV. MSI X, properly done and completely done, should be able to replace most of your AppV usage if you want it to. But I don't think you're going to get the same level of app compat in the MSI X runtime that you get with the AppV runtime. So you're still going to have some applications. If you're already using AppV, you're going to want to stay with it for those apps. Question becomes, are you going to get benefits by turning them into MSI X? If we're talking about applications that you're really not going to upgrade, because it is that thing that just you're going to use it until it dies, I'm not sure that there's any benefits to going to MSI X with those ones. You know, the ones that you're going to upgrade, yeah, and be able to have the modification package, and assuming we work out a few issues with that, that'll be good. App layering, I think when you talk about the kind of app layering that happens dynamically at runtime, I think that stuff goes away for MSI X. MSI X is Microsoft's app layering solution, quite frankly. The kind of things that some of the Citrix folks are doing with using the Citrix app layering with the appliance to build the image, that's more of like an MDT style solution with a more modern version of that and doing the layering. I think that stuff stays around for a long time. But the dynamic stuff, I think you'll just end up with MSI X where you can. Some of the stuff that's in the user environment management. So if you think about AppSense Res, where you're redirecting user data, I think MSI X can probably take out most of the need for those types of products as well. But again, you'll be able to use them in parallel, and so you can stay with those things if you want to. But you will have to consider something, which is when I had the filter diagram in there, products like AppSense and Res, when they're doing that dynamic renaming, they're doing it in a filter mode driver. So if you're doing that stuff today, you were doing it, let's say you're doing it with AppV, you were doing those changes before AppV did its VFS pathing. Now you're going to be doing those changes after AppV has done its redirection. I'm sorry, after MSI X has done its redirection stuff. So some of your rules may need to change as you move those same apps into MSI X. Okay, so even Microsoft has said, AppV's not going away. We're still going to support you. You know, we're going to help you with that process going down. But just keep in mind that I think really what Microsoft is doing is they're going to support you from that format perspective, but you're still going to need to figure out the runtime piece. And that's going to be more difficult for you. Yes, I know. My time is up. But I'm not done because I have one more job. Stop it. Okay? And that's because Microsoft is here. And I also need your support with this. We learned a lot of hard lessons. Back in 2000, we wrote the design specs for SoftGrid, which later became AppV. And it included in it a very simple flowchart that kind of looked like this. I'm kind of redoing it from memory. But it kind of looked like this, where we figured out the things that need to happen when an application wants to work with data that's delivered in your package. And so the first thing we look is we want to look in, hey, when a request comes down for that file, let me look in the redirected area to see if I have a modified copy over there. And if so, they get that thing back. If not, we take a look as, oh, well, is the file something that's actually within the package itself, right? And if it's not within the package, we can just go get that file because it's in the normal place on the local system. It was a locally deployed file, and that should get returned. And then we have to do this VFS thing, where the app asks for C, program data, whatever, but I've actually deployed that in a special spot, and the VFS overlay takes care of that type of work for us. And it might just not be one package, but we may have multiples, which is kind of the equivalent in AppV of connection groups and in MSI X of the modification package. And then finally, you can actually do it. Now, what we have in the package support framework for this stuff here right now is that we don't have this concept that we had in AppV of copy on write. So if you look at having this file delivered to the package, when you get to the point to say, oh, I found it in the package, but oh, you wanted to change it, we need to force a copy on write to happen and then have that copy be opened so that you can make the changes there directly. And right now, that file redirection shim doesn't have it. But quite frankly, I don't believe it should be in the shim at all. This is the kind of thing that just AppV does without you having to think about it in the packaging. It's built into the runtime piece. And I believe that this algorithm should be built into the runtime piece automatically with MSI X to remediate the problems with these old applications that were either writing into the wrong locations, like program files, or even writing into the right locations, such as the app data local and app data roaming that we deliver inside the package. That needs to get copied out and the modifications get made there. So that's the type of thing that the Microsoft Community Portal that they pointed out. That was one of the second link on the last slide that they did this morning. That's the type of place where you would go there and give your voice that, hey, we need these things to happen automatically. Packaging shouldn't get harder as we go to this new technology. It should get easier for the application mix that you're trying to do. Okay. So last thing is simple as this, okay? You're going to go back, you're going to talk to your boss about the things you saw here today. The last thing you should do is talk about having some big project to do MSI X migration this year. Now, down the road, maybe, but not this year, okay? So please be mildly enthusiastic as you go back. You should be playing with this stuff. It is so much easier to learn the technology when all the warts are out there, okay? Because eventually, they're going to fix those warts, and it's going to look really easy. And if you first start picking up MSI X at that point, you won't understand all of the things you'll learn by playing with it a little bit today. So you don't need to spend a lot of effort at it, but it's the kind of thing this year, it's a good time to play with it. And then later on, when it becomes really production ready, you're going to be ready to roll with it and be much more experienced so that when the pretty version fails, you'll know how to go in and debug and figure out what's going on. All right, so that's my time. Thank you very much. Oh, yeah. I'm sorry. There was one other thing I was supposed to say. I forgot. So I've been doing my AppV classes here in Europe. Today we announced the set of classes for next year. What I'm actually going to be doing is a combined AppV MSI X class. So we'll be packaging for AppV and MSI X. So look forward to seeing that. I've got 3 classes scheduled here at PDS. I've got one in Switzerland already for next year, and I'm sure we'll be announcing many more as we get through the holiday season. So thanks.